Hey everyone, so in this video we'll cover uh, inverse matrix and how to find the adjoint and the properties and rank of a matrix. These things last video we cover about what is a matrix and what are the different types of matrices and the properties and how to find the determinant of 3 by 3 and 4 by 4. So in this video we'll cover this inverse matrix and adjoint, the properties and rank. So first they'll give you one matrix. They'll ask you to find the inverse of that matrix. So this is the question. So they'll ask you to find the inverse of this matrix. So what is the formula? A inverse is adjoint A by det A. So then you have to find adjoint of that matrix, and you have to after that you have to find the determinant of that matrix. Then using this formula you can able to make the original matrix to inverse matrix. So if it is a 2 by 2, the determinant of this, there is simple one technique is there. Using that you can find the inverse of that matrix, that is 1 by AD minus BC into D minus B minus CA. So that is a formula. This is 1 by A means this is the first element, first row first element A. Consider this as A B C D. Then AD minus BC, you all know what is how to find the determinant of 2 by 2, same thing. And after that D minus B minus CA. So if you solve like this, you can able to find this one. So in this way, you can find the inverse of the 2 by 2 matrix. Simply, you have to apply that logic. Or another way is like you know how to find the determinant, and you have to find the adjoint of that matrix. Adjoint means first cofactor of a whole transpose. So then, if you want to find the adjoint, then you have to find the cofactor. Then after that, you have to transpose that. So in this way, you can able to solve this one. So let's consider this 3 by 3 matrix. They'll given you one 3 by 3 matrix. They'll ask you to find the inverse of 3 by 3 matrix. So the steps is same like uh, so first you have to find the determinant of that matrix, and after that you have to find the adjoint of that matrix. So you all know how to find the determinant of 3 by 3 matrix. Then in this example it's already the figure out like how to find the determinant of that A matrix. You got the value as 3, then you have to find adjoint matrix. So there are one technique is there. So take this matrix and assign the numbers like this: 1, 2 and 3. Second row consider as 1, and third row consider as 2, and first row is considered as 3. Then do like this. So select the middle element, and after that rotate like this, go to right, and after that from the last element go to in this direction. Give those values like here in this case 3, start from 3 0, then 0, then 3. This is done. Then come to this second one: 0 1 2 0 0 1 2 0. Next go to this third one: 0 2 5 0 0 2 5 0. Then whatever you have mentioned in the first row na, so make sure that repeat the same thing in the bottom. Then you do normal AD minus BC operations. So 3 ones are 3, and 0 0 0. AD minus BC means 0 0. Then after 0 minus 6 minus 6. So this is the cofactor. In this way you can able to find the cofactor of that matrix. This is one of the shortcut trick. Otherwise you have to go with the minors, and I hope you know how to find the minors, and I already discussed in the last video. And so in this way you can solve this one. After getting this, you will get the cofactor of that one. If you transpose that, you will get the adjoint. So simple. So A inverse equal to adjoint A by det A. So you already calculated the determinant of that matrix, and you replace this with your adjoint one. That's it. In this way you find the inverse of that matrix. Then we'll cover few topics on properties. Let's take these are properties, joint properties. Then after that we'll solve this. Okay. Let me add one more thing here. See, you have to understand these properties are very crucial and useful in order to solving the problems. They'll ask you in this way. So already adjoint a matrix is there, and they'll ask you how to find the determinant of that matrix, or they given some a matrix, or they'll ask you to find the already adjoint matrix is there. You have to find the adjoint of adjoint matrix, and you have to find the determinant. So there are predefined formulas here. If you go with a normal technical approach, like normal approach, it will be very time consuming, and it will take a lot of efforts and time and processing steps. So using these formulas, using these shortcuts, you can able to find the answers in a much more easy and efficient way. So that's why we're going through these shortcuts. So you have to this is a normal step here. So a inverse equal to adjoint a by det a. So if you interchange those things, you'll get the same formula. This is done. Then so suppose there is one adjoint a is there, and given original matrix is there, you already find the adjoint. If you multiply those things, you will get the determinant of a and I. So it will equal to the identity matrix only. That is the first thing. Then adjoint a is there. They ask you to find the adjoint of that adjoint matrix. Then the formula is det a whole power n minus 2 into a. N is order. If suppose they given 3 by 3 matrix, in this place n is 3. They given 2 by 2. In this case n is 2. So in this way, you have to find the adjoint of adjoint matrix, and they ask you to find the determinant of adjoint A. So that is a det a whole power n minus one. So this is, if you know this thing, this is enough. Then you can simply apply the same logic here to find these formulas. So I'll tell you like what are the questions, what kind of a questions they're going to ask you. So you can see this example. So given one matrix, they'll ask you to find adjoint of adjoint A. So from this formula, you can able to tell, so adjoint of adjoint is det a whole power n minus 2 into A. So first you have to find the determinant of that matrix, and after that n is dot order. So that a whole power n minus 2. A means normal, whatever matrix you have. So you can given that. In this way, you can find this one. So these are the normal steps only. They'll ask you find they given one A matrix. Suppose in normal approach, how you have to solve this one. So you have to calculate the adjoint A. Then after that, you again have to apply the determinant. So instead of that, simply what you can do, so with this formula. Determinant of adjoint is det a whole power n minus 1. So determinant A, you already figure out that. So 5 whole power 3 minus 1, 5 square 25. That's it. So in this way you can solve. I'll tell you one more um, problem related to this. Yeah, these are the important ones. See, this is not nothing but you can so they given 2 into agenda, that is say 2 is a here the scalar. So one scalar quantity given, after that they ask you to find the adjoint of it, that to product. So there is, it is a constant, right? So we have to apply k power n is the order of that matrix. Here the given matrix is 3 by 3, that's why 2 power 3 into adjoint a. Adjoint a is what, that a whole power n minus 1. So if you solve this one, you will get this answer. Then the same things normally, same formulas, determinant of adjoint, det a whole power n minus 1. Here n a is like a power minus 1. So you apply that minus logic to the upper exponential. If you do solving this one, so you'll get this answer. So this is k into a, consider k into a. So k power n, 2 power n into this one, adjoint of adjoint a. What is adjoint of adjoint a? Consider this adjoint a also a only. What is the adjoint a? Determinant of adjoint, det a whole power n minus 1. Det of adjoint a whole power n minus 1. Det of adjoint is det a whole power n minus 1. So if you multiply like this, you'll get 2 cube into det a whole power n minus 1 whole square. If you solve this one, so you'll get this answer. So that's it. This about the adjoints. Next we'll solve about adjoints, or then we'll figure out rank of a matrix. Uh, See, there are many ways to find the rank of a matrix. Like one is determinant. Through determinant approach, you can find. Another one is echelon form. So rank is very crucial in order to solve the linear equation, system of linear equations, to find the system is consistent or not consistent, and to figure out like how many solutions the system will give. So like unique solution, infinite many number of solution, no solution. Those kind of things can be determined using the rank of a matrix. So that's why we have to learn how to find the rank of that matrix. So they'll given one matrix here, so they'll give you one matrix, they ask you to find the rank of that matrix. There are two ways. One is through determinant approach you can find. So in this example, we're solving through determinant. So first I'll find the data of that matrix. If the determinant is not equal to 0, then whatever order of that matrix contain, that is the rank of the matrix. So here in this case, it is a 3 by 3. The determinant is, if in this case the determinant is 0, if it is not equal to 0, if it is something like 2, 3 or 4, something, some number minus 2, whatever, then the rank of that matrix is 3. So in this case it is 0. So then obviously it is less than that order of that matrix. So then we have two options. And you have to remember one thing, the determinant of any matrix can't be 0 unless and until it is a 0 matrix. Like all the elements of the matrix is 0, then only the rank of that matrix is 0. Otherwise it at least has one value will be there, like either 1, 2, 3, or something, anything based on the. And also you have to consider it obviously less than or equal to the order of that matrix. So in this case, we figure out like the determinant is 0, then obviously the value is less than 3 only. So either 2 or 1, it can't be 0. So these are the two options. Again, then I find one submatrix. Submatrix means within that matrix you can figure out any 2 by 2 matrix. In this case, I taken this. So minus 4, 1, 1 minus 1, 1. So this is a submatrix. I solve the determinant of that one. It is not equal to 0. Then whatever the order of that matrix, that belongs to the rank of that matrix. So that's why I got this as a 2. So so now we'll solve. mm, Rank of that matrix is done. Then we'll observe what are the properties of matrix. Then we'll go to echelon form to find the matrix, sorry, to find the rank of the matrix. So these are the major properties. I already told you, like rank of a zeroth matrix is 0 only. Rank of identity matrix is going to be n. So whatever that order might be. So rank of non-zero matrix, if the one, at least one of the element is non-zero, then obviously it is greater than 1 only. Then after that, if so they given one diagonal matrix, like only diagonal elements are there, rest of the elements are zeros, then the rank are number of non-zero elements in the diagonal. And they given there are a matrix is there, b matrix is there, they ask you to find the sum of that matrix, they ask you to find the sum of the rank of that matrix. Then it's obviously it's less than or equal to rank of a plus rank of b. And so they given one matrix A, and they'll ask you to find the rank of transpose of that matrix, then obviously both are same. And also determinant of A equal to determinant of A transpose. So these things are normal, but the most crucial ones are these things. So they'll give they'll give you one matrix as A, and they'll ask you to find the rank of the matrix, rank of adjoint A of that matrix. So then in that case, normal approach is you have to calculate the adjoint A, and after then you have to solve how to find the rank of that. So you don't need to worry about that one. So there is one shortcut is there. So if you find the rank of original matrix, based on that you can determine what is the rank of adjoint matrix. So if the rank of A is n is nothing but order. In this case, let's assume 3 by 3 matrix. So we'll get the 3. Then rank of adjoint A also 3 only. So if the rank of A is uh, so n minus 1, in this case you consider it is a 3 by 3 matrix, then in this case it is 2, then rank of adjoint A will become 1. So if rank of A is less than or equal to n minus 2, then rank of adjoint A becomes 0. So these are the major things you have to remember. Then in this case, echelon form. Okay, let's discuss the echelon form here. So these things I already told you, rank of A less than n minus 2, then rank of adjoint A will become 0. So we'll solve this one. So we'll explain this one. So before that, I'm going to explain one echelon form concept. See, I already told you to find the rank of a matrix. There are two approaches. One is using determinant approach, another one is using echelon form. So in this case, what you can do is, what is echelon form is, see, you they given already, they given one matrix to you, so you can do some row operations, row transformations. Like you can select the first row, first element, and you can make the remaining rows elements as zero. You can do those things. It is possible to do those activities in terms of a row transformations and row operations, to make the to convert the matrix into echelon form. So then after that, the rank is based on the number of non-zero elements which is present in that echelon form. So first task is like, you have to convert the given matrix to echelon form, and the number of non-zero rows in that particular matrix, then that becomes a rank of that matrix. So I'll tell you with this example. So in this case, it is an echelon form. Why? Because the if you going down, this is the first row, second row, third row, fourth row, and fifth row. You're going down, the number of zeros are increasing. You can see here, the number of zeros are increasing. Let's take one. Okay, this pen. See, see, the number of zeros are increasing, and so this is the non-zero element before one. That is also fine. So if you're coming from the top to bottom, the number of zeros are zeros are increasing. So consider this example, 1 2 3 4. So from the top to bottom, consider, so it has, this row has 1 0, this row has 2 zeros, this row has 3 zeros. It is in echelon form. It is in echelon form because the number of zeros are increasing, and that too before the value, before that value. So he, in this case, like here it is a 5. So if it is, instead of 5 it is a 0, then it is not in a proper echelon form. If it is a 6 is also 0, then it is not at all in echelon form. We have to transform the rows to find that one. So consider this example. So this is not at all in the echelon from y, because 0 0 is there, 0 0 is there, and 0 0 0 0 6. So all the three are the same thing. It's number of zeros are not at all increasing. Then it's not in that echelon form. So yeah, that's it. You have to find the transformations like row operations, and based on that you can convert that matrix to echelon form. Then based on that you can find the rank of that matrix. Mhm. What I can do? See, this we are solving in a echelon form only. So make it big. See, the given one matrix. First, you have to select the first row, first element. Using that, you have to convert the next rows as these elements as zero. That is your first target. Next, you have to select the second row, second element. Then you have to convert the remaining below row elements as zero. That is the next target. Next, third row, third element, you have to convert the next row, these elements as zero. That is the overall pattern to make the echelon form. So the given this matrix, you are doing some row operations, r2 minus 4 r1. So for this you have to obviously have to divide, I'm sorry, subtract this from the 4 times of this one, then it will become 0. So in this way you are converting these operations. Using these operations you are making this as 0. It is done. Next, it has a element, then you can interchange those rows. R2 tends to R3, you are interchanging those rows. Why? Because you have to maintain the echelon form. Because of that, then 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 what you are doing, then you, this line is, this row is in echelon form, this first row becomes echelon form, then you have these two. Then based on using this element, you want to convert this element as 0. So then obviously it will become, the entire row has become the echelon form. So if you look at this, if you look at this if you look at this matrix, then you can see here. So from the top to bottom it was increasing. Number of zeros are increasing. In this place, only one zero. In this place, there are two zeros. In the last row, it becomes all the four zeros. So if you calculate these things, the number of rows are increasing. So based on this, the rank of this matrix becomes 2. Sorry, 3. Number of non-zero rows are 3, so that's why the rank of this matrix is 3. I'll take you another image here. Rank of this matrix. See, I already told you, like, based on the rank, you can find the adjoint of that adjoint of the rank also. They given one matrix as A. They'll ask you to find the rank of adjoint A. So if you're following the normal approach, what you have to do, so you have to find the adjoint of that matrix, then you have to convert the rank and you have to find that one. So instead of that, what you can do, not directly find the rank of the original matrix and use the logic using the shortcuts. If the rank of A is n minus 2, then obviously the rank of adjoint A becomes 0. So in this way, you can solve this one. Yeah. I hope it makes some sense. So just based on the properties only, we can able to solve these things. So we covered inverse, rank, and adjoint properties. In the next video, we'll cover LU decomposition and system of linear equations and eigenvalues, eigenvectors.